Hey, what's up everyone and welcome to Daily Code Buffer. In this video, we are going to learn about the Docker. So this is a complete crash course for Docker for you busy developers. So you can understand each and everything about Docker and you can start learning Docker in your day-to-day life. Docker is a really important part of your software development journey where Docker will help you in lot of different ways, from your local development cycle to in the production. Everywhere Docker is useful. So we are going to understand each and every things about the Docker and how we can use Docker in our applications. So we are going to start with what is Docker, the architecture of the Docker, what is the differences between the Docker and the virtual machines, and lot more. We are also going to go through the different commands and different ways that we can work with the Docker images, Docker containers, how to log into Docker and everything. And we'll also see how we can work with Docker for our Spring Boot application and how we can deploy our Spring Boot application with Docker. So it's gonna cover each and everything in detail about Docker. So without any wasting further, let's get started for this Docker course. Now in this Docker course, what we are going to learn is, we are going to learn first of all what is Docker. So we will understand what Docker is and what container is. Okay, we are going to understand about each and everything about the Docker and each and everything about the container. The next thing we are going to learn is what is the difference between the Docker and virtual machine. Both gives us the similar type of functionality. Both gives us the functionality to create a virtual machine on top of a physical machine. So we are going to understand what is the difference between the Docker and virtual machine and how they differ in the architecture level and how Docker helps us with respect to the virtual machines. We are also going to see the Docker installation, how we can install Docker in our system in Linux, in Windows and Mac. So we are going to go through all those particular steps, how we can install Docker in our system. And then we are going to go towards learning all the different commands that are there in the Docker. So Docker gives us the CLI as well. With that CLI, we can do a lot of operations with the Docker. So we can create the images, we can deploy the images, we can do all the operations on the containers. So there are a lot of commands available. So we will be going through all those main commands and we are going to understand what those commands does for us and how we can utilize those commands. We are also going to see how we can debug our containers. So whatever the containers that we create using our images, in that particular containers our application will be deployed. So we will see how we can debug those containers. We will see what happens within that containers and how we can utilize the logs and all those informations within those containers. So we are going to go through those as well. We are also going to see how we can create the Docker files. There are different steps available when we have to create the Docker files that will allow us to create the different images. So we are going to see that as well. And we are also going to see how we can create our own Docker images and how we can push those images to the Docker registry. So all those steps as well we are going to see. We are also going to see how we can bundle our all the different microservices to Docker images and how we can deploy all those images in a Docker environment and how those images will interact with each other, how those images will interact with the database and the service registry. That also we are going to see in this course. We are also going to see how we can package all those applications using the zip plugin. So zip is a plugin from the Google which will allow us to combine all these steps, whatever we do as manual steps, included in the Maven lifecycle. So with one command we will be able to deploy, build and push all the images to the Docker registry. Those also we are going to do within this course. So you can see that it's going to be very comprehensive course where we will include each and everything to learn about the Docker and you will be good to go to start working with the Docker. So whatever would be useful in your day-to-day activities, day-to-day job, we are going to learn all those things. So at the end of this course, you will be able to build your own Docker images for your application and you should be able to deploy your Docker images as a container in the Docker. So now let's start with the course. Now before we go any further in the course, if you are interested to learn about the Spring Boot and how to work with the Spring Boot 3 framework and Spring Boot 6 framework, then we have created a brand new course for Spring Boot 3 and Spring Framework 6 in which we are going to cover a lot of details. We are going to cover what is Spring Framework, what is the Spring Framework 6 and the features of the Spring Framework 6. We are also going to learn about how to create your applications using the Spring Framework. We are going to learn about the different concepts within the Spring Framework, how to create the REST APIs with Spring Boot application and how to make sure that you create a Spring Boot application which is production worthy, how you can create a production grade application with Spring Boot. You are also going to learn about the NoSQL databases, how you connect your application, Spring Boot application with NoSQL databases, and we will also learn about how we can work with Kafka as well. So we are gonna go about learning the details about the Kafka, the architecture, how to connect to the Kafka, what is the way that you can publish the messages, consume the messages, and creating a Spring Boot application with Kafka. So if you are interested to learn more about the Spring Boot and Spring Framework 6, then check out the first link in the description below. And I have also added a coupon code for you to get a huge discount for the first 400 students. So if you are interested in that course, just check out that course link in the description below. Now let's back to the Docker course. So what is Docker? So Docker is a way to package all our application and all the related libraries and whatever the things that we can use within our application into a single bundle. So suppose in any of the application, if you are using Java, and with Java you are using Maven as well, and all the different libraries and your application, okay, keeping all those things differently, what you can do is you can create the package of each and everything. Okay, that means your package is created and this will be your Docker image. So you can see that you are able to package all those application and application dependencies into a single package, and that is something that you can share along with each and everyone or other developers, rather than giving all the things differently. So that's the basic definition of Docker, that it allows us to package all the different aspects of the application into a single bundle. That means at the end it's called a container. Okay, everything will be inside a container. A container, if you know the example of a ship, right? Ship containers. In a one container you will be having a lot of things. So all these things, okay, all these different applications, all the different properties or the different libraries, all will be bundled together in a container, and this container will be running in your Docker. Okay, this will be your entity that will run. So whenever you create this image, you can see that this image is become portable. Okay, which means you can pick this image and you can go to any machine and you can go ahead and deploy this application. That much portable it will be. You do not have to worry about all the different configurations and all the different libraries that will need to be installed in that particular machine. Everything will be contained in that particular container, in that particular image, and you just run that particular image. Everything will be defined there, everything will be configured very easily. Now where this image will live, right? This image will live in a container registry. Now I will give you the simple example. We have different Maven plugins. So all these Maven plugins and Maven libraries lives where? It lives in the Maven repository. Right? So everything will be there in the Maven repository, and whoever wants, they can take those data or take those libraries from the Maven repository. Similar is with the Docker images. So all those Docker images, all these Docker images will be there in the Docker registry. And this Docker registry can be public as well and can be private as well. Both type of registry are there. So by default Docker gives the Docker Hub registry, that's a public registry where all our images will live. But if you want, you can create the private registry as well, and within your organization you can create private and all your Docker images can live there, and whenever you want to use those images, you can get those images from the Docker registry and you can build your applications on that. Now why this Docker is so much important, that also we need to understand. So let's first understand that. So before Docker, what was happening is, suppose you are working on the two applications, okay, application 1 and application 2. Okay, you are working on two applications. This first application needs Java 8, this needs Maven 3.2, this is just the example, and it needs the Kafka, suppose. Okay, the other application needs Java 11, it needs Maven 3.6, suppose it needs Python 2 as well, and this needs Python 3 as well. So it's just the example where you can see that one application is been deployed with this type of tech stack, and the application 2 is been deployed with this type of tech stack. Okay, so if you're working with both this application, you have to maintain all these versions in your machine. Okay, you have to configure each and everything. You have to install Java 8 as well, you have to install Java 11 as well, and whenever you're working with application 1, you have to configure that it will use Java 8, and you have to maintain the Java 11 for the application 2. Same way with Maven, Python, and all those dependencies that you are using in your different application. But when you are using Docker, what you can do is you can easily create the images of it. You can create and download the images for Java 8, that can be easily configured. You can have the images for Java 11, that also can be easily configured, and this all are within the Docker environment itself. Okay, and you can easily access all those data, all those things from your host machine, that is your system machine, and everything whatever the application that you need will be there in the Docker environment. So whenever we'll go through the implementation, you will see how easy it is to do all those steps using the Docker. But if you were doing manually, you know that how difficult it is to maintain multiple versions of the same application, multiple versions of the same library, right? You always have to go ahead and change the different environment variables, and all those stuffs will happen. But with Docker, everything will be contained in that particular environment itself, and we can use those Docker images and Docker containers whenever we want. So it will be very easy when you're working with multiple environments to use Docker. So let's take one more example. In your team, there is a new joinee came. Okay. So for new joinee to do all those local setups, to download all the different types of libraries and different type of SDKs and everything, it will take time, right? Because you need to configure all these things for the different environments. But using Docker, what we can do is we can combine, or we can package each and everything which is required for a particular application, and with the same image, with the same package, everything can be configured easily. We can create a package, we can add the configurations and each and everything, and that we can keep in one of the repositories, one of the registries, and everyone can take that, and the local setup and everything will be very easy for the developers. So you can see there are a lot of advantages while working with the Docker. Now, other than developments, we do a lot of deployments as well. We need to move our application to the different environments. So for that as well, Docker is really helpful. So let's take the example before Docker. So before Docker, what you would be doing is, whenever you have deployed the application, okay, this application is deployed, and what you will do is, you as a developer, okay, as your application is developed, you need to go ahead and deploy to any of the environment. What you will do, you will connect with the infrastructure team or whoever is working to provide you the infrastructure to deploy application, a DevOps team or whatever, where you will tell that, okay, this is my application that I need to deploy, where I will need the Java version as 11, I will need the Maven as 3.6, I need Python as well, as 2, I need React as well, React 16, and all these requirements you will give, and you will give the configurations as well, that these are the configurations for Java, these are the configurations for Maven, Python, and whatever, all these things you will give. Alongside, you will also give that this is the application on top that you have to deploy. So you can see that you are giving a lot of instructions as well, right? A lot of instruction to the infra or the configuration team, which is helping you to deploy application. And with a lot of instructions, there might be chance like some of the instruction may be misinterpreted. So there might be chance like we need to go to and fro multiple times to make sure that whatever we want, everything is deployed correctly and everything is configured correctly. And the same way, you can see the same thing can be deployed to multiple environments as well, right? So for multiple environments, the same thing, if we have to do, we have to make sure that proper documentation or proper SOP is maintained for this, right? So if each and everything we have to do in any other environment, we can do the same step. We can install Java 11, Maven 3.6, Python 2, React 16, all those configuration we can add, and then we can add the applications on top of it. So you can see that there is a lot of hassle that we have to go through whenever we are deploying everything manually or we are deploying everything separately. Okay. But what if we are using Docker on top of it? So whenever we are using Docker, what we can do is we can package each and everything whatever is there in a particular Docker images. So what we can do, we can create the Docker images, and in that Docker image, okay, we can create a Docker image. So in that Docker image, we'll tell, okay, this Docker image will contain Java 11 with this configuration. We will tell Maven it will have with 3.2 version, it will have Python 2, it will have React 16, whatever it is. On top of that, we will add our application as well. Okay, so you can see that you define each and everything. So this will be like your configuration file itself. You will be writing the code for that. Okay, so you can see this configuration entire thing you wrote for your image. Okay, everything is there, and you can work with the infrastructure team or the concerned DevOps team to make sure that whatever the Docker image you're creating is according to standards and all those stuffs. And you can see you just created a Docker file for it, or a Docker or a configuration with which we can create the Docker images. And this Docker image is created. We can keep this Docker image in our registry, and this particular Docker image, wherever we want, we can directly go ahead, take this image and deploy easily. So we do not have to do any configuration, anything. By default, Docker will do everything for us. It will do all the operations, whatever is defined in this file, and everything would be smoothly. We do not have to worry about what is the documentation or what is the SOP and what steps we need to follow and everything. Everything is defined in this file, whatever we want accordingly, and whoever wants, if you want in your local system, if you want in your production, everything can be directly easily be done with one particular file. So you can see that there are a lot of hassle has been removed, a lot of burden has been removed whenever we are working with the Docker. So you can see that how much pain it will remove from the developer's head while using Docker. So this was all about what is Docker, why we should use Docker, and what benefit it will give us while using Docker. Now in the next video we will understand what is actually a Docker container. So what is Docker container? As we discussed earlier, Docker container is a package itself which includes each and everything with all the libraries, with configuration, with the application. Okay, everything combined together forms a Docker container, and this Docker container will be running in your Docker environment. Now how this Docker container will be created, okay, that we need to see here. So Docker container is created on base of a Docker image. Okay, so first of all there will be always a Docker image. So we will be creating a Docker image. Docker image is something that will consist of each and every configuration and each and everything. So Docker image will consist of, okay, this particular image will have the different libraries. Okay, this will have different libraries, this will have all the different configurations, this will have the application containing, it will have the operating system on top, live in the Docker registry. So this Docker image will live in the Docker registry, and from the Docker registry what we can do is whichever environment they want, whichever environment we want this application to be running, in that environment we can take this Docker image, okay, from the Docker registry, and we can have this Docker image here, and this Docker image we can run, and whenever we will run this Docker image, that is called a container. That will be the container which will have each and everything which is a running entity in the Docker environment. Okay, what this will consist of actually, you can see that we added everything, library, configuration, application, operating system and everything, but what actually it will be created of. So every Docker image is consisted of different layers. So whatever the things or whatever the application, libraries, configuration, whatever you add in the Docker image, it creates a different layers. So suppose let's take the example that you want the Java application to be packaged in your Docker image. What you will do is, I want my application to be deployed in the Linux environment, suppose Ubuntu. So you will tell that, okay, I want my application to be on top of Ubuntu. Okay, so this is going to be your one layer. Okay, and on top of that you will define, okay, on top of that install Java. Okay, this is going to be your second layer. On top of that, after that you will define that, okay, on top of Java add some of the environment variables plus do some of the configurations. Okay, these are the different steps you will be defining. So for all those steps there will be different layers. So this also will be one layer. Okay, on top of that you mention that, okay, this is the application, deploy that application in the Docker. So this is going to be your different layer, layer 3, layer 4. Okay, so this way you can see this Docker image will consist of different layers. So whatever you will add on top of it, every time there will be a different layers created, and at the end you will be getting this layer. Okay, intermediately whenever you will be getting the Docker images, you will get the first layer. On top of that this operation will happen, on top of that this operation will happen, accordingly all the operations will happen, and at the end you will get this layer and you will get the layer ID as well. So every layer will have the ID consisting for it, and whenever you will see all the information for this particular image, you can see that how many layers it consists of and what are the different IDs and everything. So we will see that as well, how we can see all those information. So at the end Docker image will consist of all the different layers, and those layers combined together will make a single Docker image, and that Docker image we can run, and that is going to be called as my Docker container. That is a single entity which will be running in your Docker environment. So from here we got to understand that Docker image and container are two different things, and how Docker image will consist of different layers, and based on the Docker image it will create a container. Now in the next video let's install Docker in our machine. Now to install Docker in your machine, go to your browser and search for Docker installation. Okay, and just go to install Docker desktop. Here if you see, if you go to the Docker desktop here, okay, this is something that we have to install. Okay, now there are two versions of Docker available, that is the Docker Community Edition and Docker Enterprise Edition. For us, Community Edition is more than enough, so we will go ahead with the Community Edition only. Now if you come here in the Docker desktop overview, in the installation part, you can see that you can install in your Mac as well, you can install in your Windows, and you can install in your Linux as well. For each and everything there is a different way to install. First let's see how we can install on the Mac. So if you go here, install on your Mac, these are the options that you will get. Install Mac with the Intel chip and install Mac with the Apple chip. So whatever machine that you are using, you can go ahead and download the package from here. I am using the Apple chip, so I will be downloading here. So once that is downloaded, it's just a normal installation. Just double click on it and it will get installed in your machine. Okay, very simple steps, you have to do nothing. Okay, so you can see that it's just an interactive installation like all the other application. So double click on it and it will be installed in your machine, and you can search with Docker and that Docker will be opened for you. Okay, that's how simple it is to install Docker in your Mac. So you can see that your Docker desktop is open and it is starting the Docker engine for you. Now let's see how to install on the Windows as well. So you can see that there is an option install on Windows. So let's go there. So from here, install Docker desktop on Windows. Here also you can see there will be a executable file. Just download that executable file and you can easily install. But with this installation, you need to make sure that some of the features of the Windows are enabled. So with Windows, you have to make sure that WSL2 backend or Hyper-V backend and Windows container, either of the one is enabled in your operating system. And you also need to make sure that virtualization is enabled for your operating system, for your machine. So if you don't know how to see, if you go to virtualization tab here, you will get all the information. So you need to enable the subsystem for Linux on your Windows machine. So if you go to the turn Windows features on and off, you can see virtual machine platform and Windows subsystem for Linux. So once you enable these two things, there will be a default update operation will be happening in your Windows, and after that update you need to restart your machine and then you need to install Docker on top of it. Okay, if you want to add the Hyper-V, the same way you have to go to turn Windows features on or off, search for Hyper-V and you need to enable Hyper-V. So for Hyper-V also it's the same thing. Once you enable it, it will start installing in your machine and then you need to restart, and after that you need to install Docker. Once you are done, you have to go to the task manager and check that virtualization is enabled or not. And from here, so if it's enabled, you should be easily be able to install Docker in your machine. Okay, so these are the steps that you need to follow to install Docker in your Windows environment. Now to install Linux in your Docker environment, there are different steps involved based on the different distribution that you are using. So if you come here, installation per Linux distro, you can see that there are different distributions available. For all those distributions, there are different steps available because all the distros use the different repository and the different commands to do all the operations. So if you're working on the Ubuntu and if you want to install Docker on Ubuntu, just go here. And here you need to follow the steps. So you can see that prerequisite is make sure that Docker desktop is uninstalled first. So you can see that it's removing the Docker desktop and it is removing all the directories and file structures and everything created whenever you have installed Docker desktop. So once that is done, you have to come here and you need to come to this install Docker desktop and you need to add the repository. Just check these commands. Okay, just follow these commands, just copy paste these commands and run in your machine, and it will be very easily installed in your machine as well. Okay, so these are the commands that you need to follow for the Ubuntu. Similarly, you can go for the Fedora, Debian or Arch Linux. So you can see that all the steps are given. Everything will be very easy to install. Once the Docker is installed in your machine, either it will be Mac, Windows or Linux, whatever the steps that you have followed, once that is done, you can go to your terminal, and if you just check the Docker version, Docker -- version, you should be able to get the Docker version. Once you get this, then Docker is successfully installed and Docker is correctly installed in your machine. Okay, we are going to use the Docker CLI a lot in this course, so make sure that you are able to access Docker from the CLI, and you should be also be able to open your Docker desktop, and there also you should be able to see each and everything correctly. Alongside Docker, you can also create the account in Docker Hub. Docker Hub is a default registry provided by the Docker itself, and here you can see a lot of different images. Okay, so if you see here, this is my account, okay, daily code buffer, and these are my repositories, my images, okay, which I have created and uploaded in the Docker Hub. But if you go to explore, here you can see the different official Docker images as well, and verified publishers, sponsored OSS. There are different types of images. So suppose if you want to work with Alpine, from here you can get those information. If you want to work with Ubuntu, Python, Redis, whatever it is. Okay, so if you just go with Redis here, okay, so here if you go, you can see you will get the complete documentation, different versions available, okay, and how to use this Docker image as well. Everything will be given here, and with this you should be able to add or get those images in your local environment, and you can work with the Redis as well using the Docker. So okay, so you can see that a simple Docker pull command is given, and all those information like different versions and everything. So you can see that all the informations are given here. We just have to go here, whatever we need we can get those commands. Everything will be mentioned here. So this was all about how to install Docker in your machine and what is Docker Hub. Make sure that you create your own account as well, so whenever we are doing any operations, we can connect to our Docker Hub as well. Okay, so that's all in the installation video. In the next video, we are going to see what is the difference between Docker and virtual machine. Now, what is the difference between Docker and virtual machine? Because both Docker and virtual machine provides us the virtualization to use for our applications. So first, let's understand the different layers that we get for the operating system. So we have one layer, that is the hardware layer, right? We will be having our hardware. This is your computer, PC, anything, server, laptop. Okay, this is your hardware layer. On top of the hardware layer, what it will be? It will be having the operating system kernel. Okay, your kernel layer. Now based on the kernel, your operating system would be, okay, different operating system will be having the different OS kernels, and on top of the kernel and operating system, you will be having your applications. These are the different layers: level 1, level 2, and level 3. So these are all the layers. Now let's understand what different layers are being used by Docker and virtual machine. So if you scroll down here, let's create another diagram. Okay, I'll just mention hardware, OS kernel, and application. Okay, so I have just created 3 layers: application, OS kernel, hardware, and this is for Docker and this is for virtual machine. So what virtual machine will do is, virtual machine will create a layer of application plus OS kernel on top of your host machine. Okay, so suppose if you have installed Windows in your machine, okay, so that Windows is your host operating system, okay, installed in your hardware. So with virtual machine, what you can do is, there are different applications that allow us to create the virtual machine, like Oracle VirtualBox. There is a option from the VMware as well. So there are different options. So what it will allow us, it will allow us to install the different operating system all together. So suppose if I want to install Linux, right, on top of the Windows, we can allow. If you want to install Mac on top of the Windows, there are options, okay, available to install Mac on Windows. So my point is, using VirtualBox, we can do that because it will consist of the OS kernel level as well plus the application level as well. So this will have the different kernel and operating system. This will have the different kernel and operating system, and on top of that, it will have the applications as well on top. Okay, and on top of that, it will have its own applications as well. So with this 2 layers, you can see that this is what we can achieve. We can install any operating system and any applications on top of it. But what Docker will do is, Docker will just use one application layer only. Okay, it will use the same OS kernel level, and on top of that, it will allow us to create the different virtual environment for the different applications. So suppose if my OS and kernel is Linux, so then we can only use the Docker images. Those are based on the Linux environment. Okay, so if I want to install Java, I want to install WordPress, all these applications we can add on top of the OS kernel layer. Okay, it will not contain any operating system and any kernel layer. It will just run as the application layer on top of the existing OS and kernel based on whatever the existing kernel would be. So with this, the size of these images or size of these containers will be very low. Okay, and on the other side, virtual machine will contain the OS, kernel, and the application, everything. So the size will be huge. So ideally on the architecture level, this would be the difference, like on which layer our Docker will work and which layer virtual machine will work. Both works very separately. Both of them, the use case of both of them are also very different. As we only need the application layer, we need only application to have the different versions and everything. Docker will help us a lot here. It will also have very less file sizes. All the image sizes will be very less as well. So those are very portable and we can move around all those in any of the environments as well. Now with this difference, I also need to explain you one thing, that is the how different it would be. Like suppose this, if you take the virtual machine example itself, right? So your host machine, that is your main host operating system, right? Like on top of your hardware, whatever the operating system which you have added, that is your host. And on top of that, whatever you add using the virtual machine, that will be your VM. Okay, that VM will be, like suppose this is Linux, right? So this environment is completely isolated with this environment, okay? Because this will have its own operating system, kernel, and all those layers. This will have its own layer, okay? But we can access this using our host and we can access this using our virtual machine environment. With Docker, that's the same thing. We have the host environment, okay? This is our host environment, and within the host environment, we can have different containers, right? These are the different Docker containers we can deploy, right? Now with this, one thing I need to make you understand is, because this is the thing that we are going to use a lot in the Docker, is this container image will have its own IP address, has its own port number, like application will be working on port number. Suppose this within this container, we have the application that is running on port 8080. Okay, and within this container, there is an application running on port 8080. This is possible because this will be isolated to this particular container and this will be isolated to this particular container. So both this container can run on port 8080. But for your host machine to access this, it can have only one 8080 port number, right? We cannot have multiple port numbers. Okay, so here comes the concept about host port and the Docker port, okay, internal Docker port. So where we can always go ahead and access the port information. I can define the configuration such a way that with this container, which port is 8080, I want to access this port 8080 from my host port, that is 8080. So you can see that these two ports are same. But for the container 2, it also has port 8080 and I cannot access with port 8080 because I have already assigned here. So here I can define with port 8081 as a host port. I can define that with 8081, I want to use the port 8080 of the container 2. So you can see that both as internal are working on port 8080, but on my host environment, I have configured in the different port information. So I can access both the application at the same time with the different port information. So this type of configuration will be doing a lot in our Docker codes as well, in our different applications. So whenever we are doing that, we are going to define this host port and the actual port that application is using. Okay, so make sure that you understand this host port information and the actual Docker port information. So this was all about the differences of the Docker and the virtual machine, how at the architectural layer, which particular layer it uses. Docker will use just the application layer, but the virtual machine will use the application layer plus the operating system and kernel layer. So in result, Docker will be having a much lower file sizes and it will be very portable to move around to deploy on any of the environments. So with this being said, let's understand the different commands available in the Docker and how to use those commands. So now let's see different commands of Docker. So what we will do is we will work with one of the image. So let's go to the Docker Hub first. So let me go to the browser and let me go to the Docker Hub here first. And I will go to the Explore here. And here you can see that I'm getting a lot of images, right? You can work with any of the images you want. For this tutorial, let's work with the Redis image. We will install Redis using the Docker and we will see the different commands around it, how we can navigate through the different things using the Docker and the Docker containers and images, everything. And we will also see how we can go inside the containers as well. So let me just go to the Redis here. And if you come over here, you can see there is a lot of different versions available. And you will also see the documentation available, like how you can run the different commands and what are the commands that you can use to install Redis in your system using Docker. Okay, all these informations are available, everything. And you can see that by default you will get one command, that is docker pull redis, which will download and install or start the container in your local machine. Okay, so what we'll do, we'll start with this command, that is docker pull redis. So we have just copied the command and we will go to the terminal. Okay, and make sure that your docker is working, docker is started, and then what we'll do, we'll just copy this command and we will run this command. Okay, pay attention to the screen, that what is happening when we do this command. So we have just added the command, that is docker pull redis. Okay, and we will hit enter, and you can see that it is trying to use the default tag, that is the latest. By default it will always do that. Okay, and you can see that the next is it is pulling from the library redis, and you can see it pulled all the things, everything over here, and you can see that you got all the different IDs here. Okay, these IDs are nothing but the different layers available. We talked about earlier as well, like all these images will be having the different layers, right? So you can see these are the different layers. With those layers it will create a image for us, and at the end you can see that the status, that is downloaded newer image for redis colon latest. This is the tag, that is the latest version. Okay, now your image is downloaded but it is not running. So if you want to see what are the images available, we can see using docker images command. Okay, so with docker images you can see that you have one redis repository with the tag latest. This is the image ID. Okay, and what is the size of the image itself. Okay, so this way you can see that whatever the images are there, you can see all those images. So you can see that we saw two commands, that is docker pull command and docker images command. Okay, now how to run this image? So to run this image we have to use the command, that is docker run. Okay, so let's see this command. If you want you can get this docker run command as well. So if you go over here and if you scroll down, you will get this command, that is docker run. You can see this docker run command is also available. Okay, so let's use this similar command itself. So what I will do is I will use docker run command. Okay, and after this command docker run, what you can do is you can give the name of the container you want to create. So ideally what we will be doing is we will be using this image to create our container. Okay, we talked earlier as well that images will have all the different layers and everything, and with that particular image we will spin up or we will start our container. Okay, and that container will be our running entity. So now with this image, whatever we have, we need to start our container. That container will be having redis running inside it, and we can access that redis. So now with docker run command over here, after this I can give the name of the container. So with hyphen name I can give the name of the redis. So I can say redis latest. Okay, this is the name that I gave. Then after that you need to give the image ID, with which image ID you want to create the container. Okay, I want to create the container using the redis repository, that is the redis image. Okay, so I can give redis over here. If you just give redis over here this way, then it means that it will assume that you are assuming the latest version available with the tag latest. So by default if you don't give anything, that means it's expecting docker to get or work on the latest tag. If you have the different tags available, then you can specify which tag you want to use. You can add using the colon, and you can add the tag as well, that I want to use this latest tag. If you don't want to give this as well, rather than the name and the tag information, you can provide the image ID as well. Okay, you have two options, whatever you want you can give the options available, and we gave the options here. So this particular command will run redis for me with the name redis latest, and the image it is going to use is redis colon latest. Okay, so once I run this command, you can see that the container is started. It started, the redis is starting here, and redis version, and all these are logs available, and at the end you can see that it's ready to accept the connections. Now if you want to see this container, let's see this. So let me just open the new tab here, and if I see docker with ps, okay, this will give me the list of containers available. So you can see that this is the container with redis colon latest image. We created the container, and that container ID is this, and the command it's executing is docker entry point.sh. It created 50 seconds ago, and the port it is exposed is 6379. Okay, and the name is redis hyphen latest. Okay, you can see all those information available here. So from here you will be able to see that what are the different containers running. Now you can see the container is running, but one thing you can see, one important thing here is you can see that 6379 is the port exposed. Okay, this is one thing. but this is the port exposed inside your Docker container itself, not from the host port. So from the host machine, you are still not able to connect to your Redis. You won't be able to connect. So for that, we need to add another extra configuration as well. So what I want to do is, now suppose you want to do some configuration change or anything, whatever you want to do, right, by running this command. Now this container is running. Now you want to stop this container, or you want to delete this container as well. So to stop this container, what you have to do is you have to run the command that is docker stop and then the container ID, or you can give the name of the container, whatever is feasible. Either of the two you can give, because that will be the unique identification for a container. So I'll just give the container ID. Okay, once I give this container will be stopped. You got this particular ID back and this container is stopped. Now if I see docker ps, you can see that there is no container available. Okay, so your container is stopped, but this container is only stopped, not deleted. Okay, if you want to see what are the containers available which are not running but those are available in your system, then you can using the docker ps command space -a. -a means all. Once you hit this, you will be able to see all those containers which are still not running currently, but those are available. You can see that this was exited 32 seconds ago. So 32 seconds ago, we stopped this container. This container will have all this status available. Like whenever this container was running, this container was running with the name Redis-latest and it was not exposing any port to the host information. Okay, so this stopped container, if you want to start it back again, then you can use the command that is docker start command, and you can give the container ID or the container name. So just pass this and the container will be started. If you go ahead with docker ps command, you can see, you will be able to see that this container is running. It started 5 seconds ago. Okay, so now what we will do is we will remove this container. So let me just remove this docker ps, not ps, docker stop command, because we need to stop this command, stop this container first. So I will copy this container ID and I will stop the container. Now once the container is stopped, if you want to delete, let me just clear everything out first and let me just see docker ps. Nothing is available, right? If I see with docker ps -a, this container is available which is stopped. Now if I want to delete this container, I can delete by using docker rm command, that is remove command rm, and then you can give the container ID or the container name. And you can see that you will get the response and this container will be deleted. Now if you again see with docker ps -a command, there is no container available. Okay, so your container is deleted, but your image will be still there. If you see with docker images, your image is still there. So let me just clear this and let me just list down the images. And what I will do is I will start this image with port expose as well. So let me just run this command again, docker run -name, and I will name as Redis-latest. Okay, and this should be using the Redis:\latest as the image. Okay, now what I want is I want to expose the port. 6379 was the default port and that was exposed within the container. I want to expose that port for my host machine as well. So my host machine will also be able to access this container, because ideally that's the use, right? That's what we are going to try. That's what we are going to use Docker for. So what I will do is I will define that with -p. Okay, -p will allow us to expose the ports. So what I want to expose is I want to expose 6379 port of the host. This will be your host port for the container port. So container port is again 6379. Okay, so this 6379 port is there of the Docker container. I want to expose the same as 6379 for my host machine. So from my host machine, I will be able to access Redis with 6379 port information. Okay, and what I want is I want to start this Docker in the background mode, in the detached mode, so I can do other operations as well. I don't have to wait until this, or if I close this screen as well, this Redis should be running. So I can define -d to start this in the detached mode. Once I hit enter, you can see that you got the SHA ID and your container is started. Now if I again go and see docker ps command, you can see that your container ID, your image ID, your command that is been used to start at the starting of the container, it created 5 seconds ago, and now you can see that 0.0.0.0 colon 6379 for 6379 of the container. So you can see earlier you were not able to see this, so your port was not exposed for your host system. Now that port is exposed for your host system. For which port? That is the 6379 same port. Okay, so all this information you can see that it's available. Now consider one scenario that you have to use the different versions of Redis for the different application that you're working on. Currently you are using Redis latest, right? For one of the application. You have the scenario that you want to work with a different version of Redis for the different application. So how you should be able to do this? Okay, currently if I see with docker images command, you have one Redis available, that is Redis with tag latest. Okay, so if I go back to my browser, and there are different versions of Redis available. Okay, what I want to do is I want to use a different version. Suppose I want to use the 6.2.7 version, okay, for my different application. So how to get that? So to get that, what we can do is, let's go to the terminal again. Let me just clear this out, and let's see the images only. Okay, these are the images. Now to get the different version, right, what we will do is we'll just define docker pull Redis. Okay, if we just pass Redis this way, then it will by default take the latest version. Okay, but if we define the specific version with colon here, that is a tag information. So the tag I want to use is, the version I want to use is 6.2.7. so let's define 6.2.7. okay, once we run this command, this particular version will be pulled from the Docker repository. So let's wait for that to complete. First of all, it will check that if that version is available within my local repository or not. If not, it will fetch from the Docker Hub repository. And you can see that it was pulling this version and all the different layers pull completed, and this is the digest version, and downloaded the newer image for Redis 6.2.7. okay, now if I see Docker images, you can see that there is a two Redis version available. One Redis is the latest, one Redis is the 6.2.7. both is having the different image ID. Okay, so both of these images are of the different versions. Currently I only have the one container running. Now if I want to run this Redis as well, I can do the same thing. I will use the same command here. This is the command. Okay, docker run --name Redis latest. So what I will do, rather than latest, I will define Redis old version. Okay, and the tag information I have to use is, rather than latest, I have to use 6.2.7. This is the Redis image that I'm going to use to start this container. Now this container, Redis will always by default start on 6379 port information. Okay, now for my host information, my host, I have already exposed 6379 for my host. The same I cannot use multiple times, right, because that port is already used. So I have to change my host port. I can change to 78, suppose 6378, but my container port is still 6379, because in my container, Docker container, Redis will still work on 6379, but for that port, for my host machine, I am exposing 6378. Okay, if I run this, container should be getting started for this as well. So if I run this, so you can see we got the digest. Now let's clear the screen and see the Docker containers. So to see the Docker containers, we'll again do docker ps command, and you can see that these are the two containers. This is the first container ID with the image Redis 6.2.7 with the command 13 seconds ago it was created, and you can see the port information. The port information that is exposed is 6378 for 6379, that is a Docker container port. And you can see that this is the different container ID still running the Redis on the different ports. So you can see at the same time I am able to run two different versions of Redis on two different port information. You can see how easily I was able to do this, right? Just one command I was able to start both of them. Now with your application you will be able to easily connect this. So you can see that we saw a lot of commands, right? We saw the docker pull command, we saw the docker run command, we saw docker images command, we saw docker ps command as well, and we saw docker stop command, we saw docker start command as well. So you can see we saw a lot of commands, and these are the commands that you will be using day to day. Now if you want to see more commands, what all the different commands do, you can always go ahead with docker command, and with -help you can get more information. So you can see with -help you will get the complete manual, like for the docker main command how many commands are available, and for a specific command as well you can do the same thing. If I clear this out and if I see docker run command and I want to get the help for docker run command, I can get. So for this docker run command, these are the different options that you can pass to do the different operations. So all these informations are available. So you can always go to this particular manual and you can get the information like what particular command will do, what are the different options that you can get to do all those operations. So it's really easy to go through the different docker commands, and these are the basics that you will be using. Now in the next video, we will understand how to debug our docker images and containers. Now let's see how we can debug our containers and images. If you see docker images here, okay, we have all the docker images, and if you want to see all the stale images as well, you can get using the docker images -a, the same way that you used to do for your containers. You will get all the images. Okay, now suppose you want to see what all the things are there for this particular image, okay, for docker 6.2.7. okay, what are the configurations and environment variables and everything directly. So for that you can use the command docker inspect, and you can pass this image ID here. Okay, and once you do this, you will be able to see all the information for this image. Okay, so this is the JSON format that you will get, and you will get to see all those details. So you can see that the ID of this image is this. Okay, this is the repo tags, this is the digest information, is there any parent for it, when it was created, what is the container created for this particular image. Okay, that information you will also get. You will get the information about what environment variables are set for that particular image. You will get to see what are the commands added, like which commands will run when the container should start for this particular image. Okay, is there any volumes attached? Okay, what is the working directory, what are the entry point commands, all this information. You can see which docker version is there, who's the author, configurations. Okay, all this information is there, and from here you will be able to easily identify what's going on for this image. Now let me just clear this and let me go to the docker containers. The same thing you can do for your containers as well. So if you go to docker inspect and use any container ID to inspect that container. Okay, so you can see you are getting the same information here. Okay, but this information will be particularly for your containers, not the images. So these are all the information. You can see that this is the container ID, when it was created, the path where the entry point command is been added, what are the arguments, okay, what is the state of the container, currently it's running, right, when it was started, what is the image used, and you will also get the information regarding the IP address. You can see what are the port information. Okay, port bindings, 6379 port is bind to the host port as 6378. Okay, all this information you will get from this particular command. You will also get the IP address and everything here. So if you want, you can explore these commands, and these commands will be helpful when you want to write your bash scripts. Okay, if you want to get the particular information, and based on those information, if you want to do some operations, you can always do that. So these are the, you can see the IP address and everything, right? So these are the two commands that you can use to inspect your images and containers. Now let's see how to see the logs. So if I have the containers available, right? So now if you want to see what happened or what logs are trailing for this particular any container, right? Because in any of the container you will be deploying your application, and that application will be constantly spitting out the logs, right? So if you want to see the logs, you can use the command docker logs, and then you can pass the container ID. Suppose I'm passing the first container ID. Okay, and with this you can see the logs available. Currently for this there are only this much logs available, so you can see this much logs. So whatever logs are there, all those logs you will be able to see for a particular container. Okay, so these are the logs available. So with the logs command, you just pass the container ID and you will be able to see the logs for that. Let me clear it again, and let me just list down again the containers. Now suppose with the logs you are still not able to identify if there is any issue or anything that you are trying to understand. So what you want to do is, what ideal thing we would do is, we will have to go inside the container and see what is happening, right? So to go inside the container, okay, the command is docker exec. Okay, That means you are trying to execute any of the commands within that container itself. So this is my container, right? I want to log in, or I want to go inside that container, and then I want to execute some commands. Those are Linux or whatever the commands, and you want to do some operations on it. Okay, so once I go in, so what I want to do is, once within this container, I want to log into this container, I want to go inside this container, and I want to start, or I want to log into the Redis inside it. Okay, so the command is docker exec, okay, docker space exec, and then -it. This means that you want the interactive mode to run the commands. Okay, so with this you will be able to access the shell of the particular container, and with that we will be able to access the different commands. Now after this, we need to specify which container you are trying to access. So we can give the name, or we can give the container ID. So let me give the container ID, and after this container ID, what command you want to run. For this container, we need to pass the command, that is /bin/sh I want to run. And you can see that your cursor is changed. So now you are inside the container. So if I just do ls here, if I do just pwd, you can see that you are inside /data folder. If I just go back here, and if I do ls, you can see these are all the folders of the container itself. Okay, so I'm inside my container. Now if I want to log into my Redis, I can do using the Redis CLI command. You can see that I just logged into the Redis inside my container, and I can do all the commands, keys star, if I want to check all the keys and anything. Okay, so you can see that how easily I was able to go inside my container as well, and within container I can do all the different operations as well. If I just want to come out of it, I will just use exit command to get out, same way exit command to get out. And if I do ls here, you can see these are the different folders of my host machine. So this is the difference. This is my host machine, and this was your container. Okay, so this way you should be able to go inside your container to run the commands. Also, you need to make sure that different container uses different shells. Okay, so currently this Redis is using sh, some may be using zsh, some may be using bash as well. So accordingly, you just need to identify. If it's not working, try with bash or zsh, it will work. Okay, any one shell will be available for sure. So this way you will be able to get inside your containers as well. So you can see we went through a lot of commands, and we saw the different ways to debug and inspect our images and containers as well. Now in this section, let's understand how to clear out everything. Okay, if you have multiple containers running, or if you have multiple images and everything, if you want to clear it out everything, if you want to clear your Docker environment, how we can do this. Okay, so let me just clear this out first. And if I see Docker images, okay, currently you have 2 Docker images, and if I see docker ps command -a, you can see that you have multiple containers also available. Okay, so one thing I will show you is, if you want to clear everything, you need to make sure that your all the containers and everything are stopped. Okay, so if I just do docker ps, not ps, sorry, stop, and I can pass both the containers. Okay, this is the first container, and this is the second container. I can pass with space, and now both the container will be stopped. Okay, so you should be able to stop multiple containers this way. Now if I just do docker ps, no container is available, docker ps-a, all the containers are there. Okay, suppose consider you have many containers, and deleting with rm command one by one is also not feasible. Okay, and if you want to delete the Docker images, let me just clear it out, and let me do docker images command. Okay, and if you want to delete the images, the command is docker rmi. For containers it is just rm, but for images it is rmi command, and then you can pass the image id or the image name :tag name to delete that particular images. So that command is also something that you can use. Okay, if not, if there are multiple images and everything, if you want to clear each and everything by once, okay, there are different commands available inside the Docker system. So within this Docker system, there is a command that is prune. Okay, this will prune everything. You need to make sure that nothing important is available. If you have to take backup, you can always take the backups and everything, but this will delete each and everything for you. So if you just pass docker system prune -a means everything, and just hit run, you can see that you will get all this warning here. This will remove all stopped containers, all network not used by at least one container will be removed, all images without at least one container associated to them, and all build cache. Everything will be cleared if you run this command. If you just hit Y, you can see that everything is removed. Now your space is claimed back. And if you clear this now, and if you see Docker images -a, no images available. If you see Docker ps-a, no container is available. So everything is clear, and now your Docker environment is fresh now, so you can again do all the operations on it. Okay, so why I showed you this is because we are going to work on the Docker, and there might be times that we did something wrong or anything for just trying out some different things, right? So make sure that you can clear all those things this way. Okay, so this is the handy command as well. Now let's talk about how to create our own Docker images, because currently till now we saw that we were using the different Docker images available in the repository. Now how to create our own Docker images using the Docker file for our applications. Okay, so earlier I mentioned that for every Docker images there will be a Docker file, and with those Docker files we can create our images. So if I just show you for the Redis as well, okay, we use the Redis, right? So we use this latest version, right? So if you go to the latest version here, so for this latest version as well, you can see there is a Docker file where all the different commands are mentioned, like create this Docker image from the Debian, run this command, set this environment variables, then run this again commands, okay, then set the different environment variables, run these commands, and you can see all those different steps are mentioned here, and all these different steps are the different layers added to it, and at the end you will get one layer which will be having Redis installed on your system, and you will be able to easily access Redis. So this way you can see that with a Docker file your images are created, and those images you will be able to run as a container. Okay, so for our application as well, whatever the application that we are going to create or we had created, for that also if you want to create the images that can directly run, that means we have to create our Docker files, right? So let's see how we can create the Docker files and how we can run those Docker files to create our images, and with those images how we can run our containers. So for that, let's go to the IntelliJ IDEA. Okay, and we have different applications available. Okay, there is a cloud gateway, config server, order service, payment service, product service, and service registry. These are the different applications that we have. Now for this application, we want to create our Docker images, all the different Docker images for the different applications, and within that Docker image I want to bundle my application, and whenever I start my container, my application should also start. That's what something I want to do. So what I will do is, let's start with the service registry first. Okay, so within the service registry, let me just close all this files here. Okay, so within this service registry you can see that we have the application. This application will be running on port, let me just see, on port 8761. Okay, this is nothing but our service registry where all the services will come to connect. Now this application we need to create the image of Docker image. So for this we need to have a Docker file, right? So let's create a Docker file. So within this root directory itself, I'll create a new file, and I will mention this as a Docker file. Okay, simple, DOCERFILE, and your Docker file will be created. Now here we can add the different commands. So if you see over here, these are the different commands, right? Similarly, we will add the commands here. So what I want to do is, I want to use an image. That image will be based on the Linux, and it has the Java installed in it. Okay, so that is something that I want to use. So I will define here from my base image. So my base image I want to use is OpenJDK. Okay, OpenJDK, and the version I want to use is 11. So yeah, you can see that one step is done. We just define that which base version I want to use. Ideally, you always have to make sure that whatever the command that you write here and whatever the base image and anything that you use, you always make sure that your image size is as low as possible. Okay, so ideally at the time I've seen that people tend to use the Alpine OS. Alpine is a Linux based distribution which is very lightweight, and on top of that you will add the different applications that you want to use. It will not come with all the basic applications and anything. It will be just a bare bone Linux, and on top of that you will be adding whatever you need. Okay, but here we are using OpenJDK because I want my Linux layer. On top of that I want the Java install with all the different things, so I do not have to worry about each and everything. Now once this is done, what I want to do is, I want to add my jar application, my jar file. Okay, so service registry.jar file will be created, right? Whenever we build our application, that jar file I want to copy inside my container or inside my image, and that jar file I want to start when I start my container. Hope you get the idea. So if I open this in the terminal, okay, let me open this in terminal, and if I do maven clean install here, okay, you can see that the build is successful. And when the build is successful, inside the target directory, you can see that your jar file is created, right? So this is a jar file that we use to start our application. So whenever we will run this jar file, your application will start, your Tomcat will start, and on top of Tomcat, your application will be deployed. Okay, this is how generally it works. So what I have to do is I have to get this file and add in my image. Okay, so for that, let's do that. So what I will do is I will refer this file in one of the argument in one of the variable, and that variable I will use to copy the file. So I'll define argument as arg, okay, and I will define the name, that is jar file. Jar file equals to, where is my jar file? Jar file is inside my target directory slash I want star.jar, any jar file available. Okay, we have one jar file available, so that jar file will be picked here. Once I pick this jar file, I want to copy, so I'll use the copy command to copy this variable jar file. So I can refer this variable with $braces jar file. Okay, I want to copy this file space, that means this is going to be your source. After space you need to pass the destination. So destination I want to pass as service registry.jar. So I want to copy this file, that is service registry -0.0.1-snapshot.jar to my image with the name service registry.jar. Simple thing. So I just renamed my jar file here. Then once I copy this, I want to start this jar file. Now to start this jar file, I had to pass the command, that is java-jar, and the name of the jar. That's the command that we use to run our jar file. Okay, and that command I want to run when my container starts. Okay, so whenever you want to give any command at the time of starting your container, last command, that command you will give as the entry point. Okay, if you want to run any other commands, you can give using the cmd command. Okay, that will be run when you're building the images, but while starting your container we will define entry point. Okay, this will be used when your container is started. So at that time I want to pass multiple commands. So I want to pass java command, then -jar, then I want to go inside the directory, working directory, and I want to start this service registry.jar. So my java-jar / service registry.jar will be called when the container starts. Okay, and when my container is started, I want to expose that port as well, like which port I want to expose so my host system can access that port. Okay, so this particular application will be running on which port? 8761. So I will be exposing that port. So expose port, which one? 8761. So you can see that your Docker file is created. So you can see how simple it is to create your Docker file. What we did is we used the base version, base image, like which base image I want to use. I want to use OpenJDK 11. My application is also going to run on Java 11. Okay, that's why. And I have a jar file available. That jar file directly I have to use. So I will just define that this jar file I want to use. Then I define that copy this jar file inside my image. And then I define that entry point command. So whenever my container starts, which command I want to run, I define that I want to run java-jar service registry.jar, and then I expose the code. Now what I have to do is I have to build this image. Okay, you just define the Docker file. Now with this Docker file you have to build your image. So to build your image, let me just clear this. Okay, so to build your image, the command is docker build. Now with this command, your Docker will build the image based on the Docker file that you mentioned. Now if you've seen that every Docker image will be having its repository name and the tag version. So what I have to give is, if I go to my Docker hub, I will just show you here. Okay, so if I go to my, now you can see that these are the direct images. Okay, repository name, because these are official images. For that there is a permission to do that, but for our purposes, if I go to my repository, I already have few of the images created. You can see these are the different images. Okay, so for everything you can see there is a repository name, that is daily code buffer / then the image name itself. Okay, this is how it is mentioned. So similarly I have to do the same thing. So what I will do, I will mention this way and make sure everything is in the smaller case. So I'll just mention daily code buffer. Okay, this is my repository name slash I have to give the image name. Image name I want to give is the service registry. So I'll just mention service registry, and then I can give the tag information, like what is the version of it. Okay, so my version is 0.0.1 first version, so I'll just define 0.0.1. clear? So docker build, then the repository name slash image name colon tag information, and then you need to give the file information. So what Docker will do is Docker will by default search for the Docker file mentioned, and for that you just need to mention the directory. As I'm in the same directory, I will just mention dot that from the current directory I want to find the Docker file and build the image for me. Cool, right? So I'll just run this command. Okay, and there is some error, yeah, because we did not define the tag information, right? So this is the mistake that I did. Don't worry. So I need to define -t that this is the tag I am using, daily code buffer slash service registry colon 0.0.1 and from my current directory. Okay, now if I run this, it should work. And currently you can see that it started building, and it will add the different layers, and it will combine everything, and one image will be created for us. So you can see that all the different steps are going on. Okay, these are the different layers, you can see that, and you can see it is showing these different steps as well, that which step it is performing. So first time it will take some time, but from the rest of the time it will be very fast. Cool, and you can see that everything is done and your image is created. Okay, so if I go to my terminal again, okay, and if I see docker images, okay, I can see that the image is created, daily code buffer slash service registry, tag is 0.0.1, the image ID created 17 seconds ago, and this is the size. Cool, right? So you can see that how easily I was able to create the image out of my Docker file. Now let's see how we can run this. So to run this Docker image, we have to again use the docker run command. Okay, currently if I see there is no containers available. Okay, so I want to run this. So my command would be docker run, then I want to run in the detach mode, and I want to pass the port information. Okay, so my port would be 8761 for my host and 8761 for my Docker container, because 8761 is the port in which my application is running. Cool, right? After that, I need to give the name of the container. So I'm just giving service registry. Okay, so once this is done, service registry we have defined, and then I need to give the image name, which image name I want to use, or you can use the image ID as well. So let me just give the image ID, which image ID I want to use. So with this command, I should be able to create my container, and I should be able to access my application. So let's run this, and you can see that we got the digest SHA, and if we go and see docker ps, you can see that one container is available. Okay, this is the container ID, this is the image, and this is the command that we use, java-jar, and it was created 8 seconds ago. This is the port information. Okay, and this is the name of the container. So let's go to the browser and let's see if it is working or not. So we'll go to the localhost colon 8761, and it's not working because my spelling is wrong. Okay, you can see that your application is up and running. Cool, right? So you can see that how easily we were able to dockerize our application, create the image out of it, and create the container out of our application. Super cool, right? Now let's go ahead and do for our other application as well, that is the config server. So let's go to the IntelliJ IDEA. Okay, and what I will do is I will copy this file. Okay, and we will go to our config server, and let's paste this file as a Docker file. Cool, right? So within this config server as well, what I need is I want the OpenJDK, I want the same file, but my file name would be config server. Okay, and the same thing, this is also going to be my config server, and I will see that which port this config server is exposing. So if I go to the src main resources and application.yaml, and this is using port 9296. Okay, so let's change that. I will be using port 9296. Cool, right? So you can see that my another Docker file is also created. So now I can go ahead and build the image out of it. So I will do, I will create a new terminal, open a new terminal here. Okay, at this point, and I will do mvn clean install, because I need the jar file, right? Okay, so my jar file is created. Let me just clear the console here. Now I can build my image. So what I will do, docker build command again with -t tag. What is the tag I want to give? that is daily code buffer slash config server colon 0.0.1. okay, now you can always add the multiple tags to a particular image. Okay, so suppose let me give the multiple tag. I also want to give the latest tag for this, so I'll just define another -t and I'll just define daily code buffer slash config server colon latest. Okay, and then I need to give the current path. Cool, right? So with this I will be able to create the image of the config server. So let's run this command. So you can see that the command is started and it will be very fast to create our image. So you can see that the image is created because our OpenJDK image was already downloaded, and on top of that only we just copied our config server to our image now. So if I go back to my terminal now and if I clear this out and if I see Docker images, now you can see that I am able to see two images. Okay, you can see that daily code buffer config server, that is the 0.0.1, daily code buffer config server, that is latest, and both of them is having the same image ID, right? So that means with one image I have the two tag information. Cool, right? So now with this image let's try to create our container. Okay, so let me just do docker run command, okay, with -d in the detached mode, -p, that is a port information is 9296, right? This is the one that I need to expose, that is 9296. We just define the port information, we can define the name as well, that this is the config server. Okay, and then I can define the image ID as well, that this is the image ID I want to use. Cool, right? So now let's run this command to start our container, and we got the digest SHA, so my container should be started. So if I go ahead and see docker ps, you can see my container is started. So that means what it should happen is my service registry now should be able to connect to my config server as well. So if I go to my browser and if I refresh, so you can see that I'm not able to connect my config server to my service registry. So let's see what is the issue. Okay, so now if I go back and if I want to see the issue, what is the thing that we have to do? We have to use the docker logs command, right? So I will just do docker logs and I will pass the container ID. So this is the container I want to see the logs for, that is the config server. Okay, and you can see you are able to see the logs. So if you scroll up and I can see that there is a connection refused, right? So it's not able to connect to my service registry. Okay, so here you can see that it is trying to connect to the local host, right? And now we need to understand the important concept about the networking in Docker. So the network that has been created within the Docker environment is different than you have for your host environment, right? Because obviously it will be very different. So we need to handle this scenario as well, that whatever the local host that we are passing, so internally whatever your application is, right, that application should be able to connect to your Docker host. So because your service registry is also running on Docker and your config server is also running on your Docker, both are not running on your local host. So with local host they will not be able to connect internally, right? So we need to provide a configuration for that both internally should be able to connect, right? So for that we have to use the Docker host. So for that Docker allows us to use the host.docker.internal. So with this, if we pass that information, it will be able to connect. So rather than passing localhost, if we pass host.docker.internal, it will be able to connect. Okay, so let's use that. So what I will do is I will just stop this container and I will remove it. So let me just do that, docker ps. Let me just clear it so it will be very clear, docker, and I will just do docker stop command and I will pass the container ID to stop the container, and I will remove this container as well with rm command. Okay, this container is also deleted. So if I just see docker ps, I have only one container available. Let me clear this. Let me see docker images. Okay, now I want to run this config server again with the latest configuration. So if I go back to my IntelliJ IDEA and if I go to the config server and if I go to the application.yaml file and if I scroll down, here you can see that I have defined one thing, that this config server should go to connect to localhost 8761 when the environment variable is not available. Okay, so what I will do is whenever I'm starting my container, it will not be able to connect to localhost, right? Because we need to pass the Docker host. So what I will do is, whenever I'm starting my container, I will pass this Eureka server address as the environment variable, and in that environment variable I will pass the correct URL so that it will be able to connect. Got it, right? Why we are doing that is because with that environment variable, wherever we want to deploy, we just change the value whenever we are running the command, and everything would work easily. We do not have to change our code. So that's why we had defined the variable as well here, that if this variable is available, use that, otherwise use the localhost. So for our higher environments, we'll always pass this environment variable whenever we are running our containers. So let's define that. So what I will do is, I will go back, I will use the same command again. So let me just go back to the command. Okay, docker run -d 9296, the name and everything. And here what I will do is, I will define the environment variable with -e, and the name is Eureka server address. So I'll just define Eureka server address, and then I will pass the value. And the value I will pass is, I'll copy this, okay? And I want to remove this localhost. Instead of localhost, I need to use host.docker.internal, okay? So I will just pass host.docker.internal :8761/Eureka. The name of the container is config server, and the image that we are using is FC5SC5958A04. That's the same one, okay? So you can see that we are passing one environment variable. So with this environment variable, that particular instance URL that we have mentioned here, right, this will be replaced default zone, and it will be able to connect to my service registry. Okay, so let's run this now. Okay, so you can see that we were able to run this. If you go ahead and see docker ps, container is available, and if we see with docker logs here to see what is happening with this container, and you can see that it is able to connect to my registry, right? We are getting status 204. So if we go here and if I refresh, you can see that your config server is visible now. So your config server is now able to connect to my service registry as well, within, as both are there on the Docker environment itself. Cool, right? So you can see that now we are able to connect our applications. Now let's do the same thing for our cloud gateway as well. So what I will do is, I will go to my IntelliJ IDEA again, and I will just copy this Docker file from here, and I will add in my cloud gateway. Okay, so if I come here in the Docker file here for the cloud gateway, I have to change to cloud gateway. Okay, that's the cloud GAT gateway, and I'll just copy this name here as well. And cloud gateway is running on port 9090. Okay, so that is something that I will expose. So you can see that my Docker file is ready. So what I will do, I will just open this in my terminal now, and I will do mvn clean install. I'll just create the jar file. Okay, so you can see that your build is completed. Let me just clear this. Now let's create the image out of it. So I'll just use docker build -t to add the tag, daily code buffer as the repository, /cloud gateway, right, / I will just pass the latest version, not this way, colon, right? So you can see that I just added the tag information, and then I will pass the current directory to use my Docker file. Cool, right? So you can see that with this, I'll be able to create my cloud gateway image as well. And we'll wait for a couple of seconds to complete the process. And you can see that your image is created. Now if I go back to my terminal, let me clear this everything. And if I see Docker images, cool, right? You can see that now my cloud gateway is also available with the latest tag. Now we need to run this as well. So if I go here, right, to my IntelliJ IDEA, and if I open the src main resources and application.yaml file, okay, so here also you can see that it is in the application.yaml file of the cloud gateway, it is trying to connect to the local host, right? But within the Docker, as we see earlier, it won't be able to connect to the localhost environment, right? So we need to handle this scenario as well. Okay, for the cloud gateway, it is coming from the config server, right? So what we will do is we will need to add the environment variable for this as well. Okay, so let me go ahead and do that. So here what I will do is I will add the dollar curly braces and I will pass localhost here, and before that I will pass config server URL. So when this environment variable is available, it will use this, otherwise it will use localhost. So whenever we'll be starting our cloud gateway, we will pass the URL of the config server. Okay, so now you can see that we modified the changes. So that means we need to rebuild and recreate our image, right? So in the cloud gateway, we will do mvn clean install to create our jar file. And you can see that build is successful. Let me clear it out. So my jar file is created. Now I have to build it. So I will use the same command again, docker build -t daily code buffer / cloud gateway :latest dot to create my image again. Okay. So we'll wait for a couple of seconds to create the image, and the image is created. Now if I go again back to my terminal, if I do again docker images, you can see that it created 7 seconds ago, and you can see that this is a new image, and previous image you can see that it is marked as none. You can see that this is the same image ID, right? This and say this. So you can see that new image was created, and that new image got the name and the latest tag, and the old image is still available with everything marked as none. Okay, so whenever you will see that anything is marked as none and none, that means a new image was created on top of it. Okay, and this is pointing to nothing now. So now what we will do is we are going to use the earlier command that we used to create the config server container. Okay, so let me just use this. So you can see that this is the command that we used. Okay, so I will be doing some changes. I will name this as a cloud gateway. Okay, and then I will give the image ID, this one here. Okay, other than that I will be needing this environment variable. Okay, I will change the port information because this is running on port 9090. Okay, one environment variable we have set, that is for Eureka server address. We also need to set one more environment variable because this we mentioned, right? Currently in the cloud gateway, this is what we mentioned, config server URL. So this also we will pass as the environment variable. So we will pass -e again for the environment variable. We'll pass the config server URL equals to, now whenever internally they have to connect, we have to pass the internal local host, right? So we'll mention host dot docker dot internal. Okay, so this is one environment variable, that is the config server URL host.docker.internal, and then the other environment variable is Eureka server address, and we pass the URL, and the name is cloud gateway, and the image that we are using is this. Okay, now let's run this, and you can see that we got the image here. Okay, and if I go, let me just clear this, and if I go to docker ps command to see all the containers, you can see that the cloud gateway container is created. Okay, and if I go to the browser, let's see if it's connected or not, and you can see that it is able to connect. Okay, so you can see that now it is able to get the information of the both the environment variables that we have set, and it is taking the configuration from the config server. Okay, whatever we have mentioned, because in the API gateway we have not mentioned the configuration of the service registry. If you see here, right, if in the cloud gateway we have only mentioned the configuration of the config server, not for the Eureka server. That is coming from the actual config server. Okay, whatever we have mentioned in the GitHub. So you can see that everything is coming together, right? All the applications are connecting. So now if you have to add any other application, you have to do the same way, that you need to create the Docker file, you need to create the Docker image based on the Docker file, and whenever you want to run, you need to run the command, you need to pass the proper port information, which particular ports you need to expose, and you need to pass the proper environment variable as well, like which particular environment variable you want to use to connect. Now for the rest of the application, it will be the homework for you to create a Docker file and to build the images and build the containers of it, and to identify which environment variable it will need, and to pass the environment variable as well. Cool, right? Now let's try to understand how to push these images to the registry. Okay, so currently you can see that, let me just clear this out, and if I see Docker images, Okay, you can see all these images are available. Okay, but all these images are available within your local repository. These images are not available in your public repository, that is Docker Hub, where you can publish those images and anyone else can use it. They can take those images and they can work on it. So for that, what you have to do is you have to go to the Docker Hub, that is the public repository available, and you can create your account. Okay, I have created the account for me and I have multiple images also available. Okay, for you it will be blank. Okay, now we can see that there are different repositories available altogether. There are different downloads and all those options also available. Now what I want to do is I want to publish this repository, that is this image, that is Cloud Gateway, to the Docker Hub. Okay, so for that, what I have to do is I have to first log in first of all, right? So you can see that you will be having the account, right? So you need to first log in and then you need to push the images. So to log into your Docker Hub using the command line, what you have to do is you have to run the command, that is docker login command. Okay, and once you hit enter, it will ask you, or it will prompt you for your username and password. Okay, you can add your credentials and you will be able to log in. But if you want to pass as the argument, you can pass -u as the username, whatever the username is, and after that -p with your password as well. That also you can pass to login. So once you are logged in, it will show that you have successfully logged in, and then you will be able to push your images. Okay, so currently let's try to push this Cloud Gateway image. So if you see here, there is no Cloud Gateway. It's a different Cloud Gateway, Cloud-Gateway, which was added a year ago. Currently we are going to add this fresh without hyphen. Okay, so here the command is docker push, and then you need to give the repository information. So I'll just copy this. Okay, docker push daily code buffer / cloud gateway latest. Okay, this is what I want to push. So I'll just run this command and you can see that it started pushing. So push refers to repository docker.io / daily code buffer / cloud gateway, and it's preparing everything, and at the end it will create the image in your repository. So we'll wait for that to complete. So make sure you log in first and then you do the docker push command, and you can see that it pushed and mounted as well. And if we go back to our Docker Hub and if we refresh, we should be able to see that daily code buffer / cloud gateway, which was published a few seconds ago. Okay, and if we go inside this, you can see that all the information, that this is the daily code buffer / cloud gateway, and here you can add all the different information. Currently the tag information, you can see there is only one tag available, and if you open this, you will be able to see the different commands as well. Okay, so all these commands, you can see that we added this command, right? Add arguments, then copy, then entry point, then expose. Rest of the commands are part of the OpenJDK itself. Okay, because we use that. Okay, so that will add all these things. Then we added all these things. So all this information you will be able to see here, and you can see that this is a command and everything came here. If you go to the public view, you will be able to see that docker pull daily code buffer / whatever it is, and you will be able to get all the information. So you can see that how easy it is to push the images to the repository as well. So we did for one, you can always go ahead and do for the others as well, and make sure that all your images are available in your repository if you want anyone else to use your. Now let's understand about Docker Compose. Currently, if you see that we have multiple images available, right? And all these images, we start using one of the commands. So all those images that we start for a container, right? To start a container for those images, we did a different commands, and those commands were used separately, and all those commands was having the different sets of environment variable, different sets of port information and everything. Okay, so what you have to do is you have to keep those commands handy whenever you want to work, or whenever you want to start your containers from the images. Okay, that's a little bit hassle as well, right? Because if you're working on 10 different images, and if you want to start all those 10 different images, then you have to go through all those commands and execute all those commands and everything. What if I tell you there is a way that you can define each and everything, whatever steps that you did for all the different commands to start your containers based on the images, into one single YAML file, and by running that one single YAML file, it will start all your containers based on the images that you've mentioned, right? It will reduce a lot of burden from us, right? Rather than remembering all those commands, mentioning those all commands, keeping it handy somewhere and executing with those commands, just have one file handy with you and directly you can execute that file. Cool, right? So let's try to create the Docker Compose file for our different applications or different images that we have created, and let's see how we can reduce a lot of work. So currently we have a lot of containers available, right? Let's stop all those containers and let's clean everything. You can see that for cleaning as well, we have to stop the containers, we have to delete it, and a lot of things, right? So let me just stop everything, docker stop. Okay, all the containers are stopped now. We'll wait for it to complete. Now I will just use docker system prune -8 to clean everything. Yes, I'll just clear it out everything. Okay, and what I will do is, let me just see Docker images. I'll clean that as well, but ideally I was needing those images. Okay, so let me go ahead and create those images very quickly. So what I need is, I need one cloud gateway. Okay, so let me just create the cloud gateway image. I need the config server. So let me create the config server, and I will be needing the service registry as well. So let me create the service registry. So all the 3 images are created for me now. Okay, so let's wait for this to get completed. So you can see that everything is completed. If I go back and if I see docker images -a, and you can see that I have all the images now. Now what I will do is, I will create a Docker Compose file that will use all these images, and within a command everything will start for me. So let me clear this everything. Let me just keep this handy. Okay, so now let's create the Docker Compose file, and with that one file we will start all the containers. So what I have to do is, I have to create a file, right? So let me just open the new terminal, and let me just go to the directory. So here you can see that all my projects are available here. So what I will do is, I will create the file here, docker compose.yml. Okay, and let me open this file. Okay, this is my Docker Compose file. Now let's write this file. So if I go back here, you can see that I have all the 3 different images available. That is the config server, service registry, and cloud gateway. Okay, so I'll mention all those 3, and I will add the configuration for it. So what is the format? First you need to define the version information. So version I'll mention as 3. Okay, so make sure that whatever the latest version is available, you use those version. Currently I'm using the version 3. And after you define this, you need to define the services. So let me define the services. Now within the services, you need to define all the services that you need to start. So currently we want to work with service registry, cloud gateway, and config server, right? So that all thing we will define. So here I will define service registry. You can give any name over here. Keep the habit to give the same name as your image name or whatever. That will save you a lot of efforts in debugging and fixing any issues. So with service registry, so with this service registry, you need to mention which image you have to use. Okay, with the image tag. So I will just mention image I want to use for the service registry. So I will go here and I will copy this. Okay, I want to use this image :0.0.1. You need to provide your repository or whatever, the entire name and the tag information as well, like which version you want to use. Okay, if we see here, this is the 0.0.1 version, right? Okay, now after that you need to give the container name. What container name you have to give? So container name equals to service registry. I'm giving the same thing. Okay, and then you need to give the ports, which ports you want to expose, and this will be list, because from the same container you can expose multiple ports as well if there are multiple applications are there within it. So for the service registry, I want to expose 8761 as a host port from the 8761 from the Docker container port. Okay, so you can see that this all information you were passing when you were starting the container from the image, right? Like which image you want to use, what is the name of the container, what port you want to expose, all this. Cool, right? So you can see that one service is done. Now let's add another service. Let's add config server. Okay, now within this config server, which image I want to use, I can define image. I will copy the image name from here. So I want to use this config server :0.0.1. Okay, and then the name of the container name I want to give as config server. Okay, and the ports information. So I want to use port config server is running on 9296 9296 :9296. Okay, config server is also done. Now the third one was cloud gateway. So let's define cloud gateway, and I will define the image, which image I want to use, and I will mention, so I just need to use this cloud gateway, and the version is latest. Then ports information, which port I want to expose is 9090, because this will be running on port 9090. So you can see that all the configuration that we have added, you can see how simple it is. We just define that how many services are there. There are 3 services, and for each and every services we mention which image I want to use to start the service, that is the container, what is the container name that you want to mention, and what is the port information as well you want to mention. Cool, right? Now one thing also you can mention here, that is which service is dependent on which service. So what I want is, whatever I mention, what it will do is it will try to start all the services together. Alongside it will create one network as well for my entire Docker Compose. So all the services which are mentioned here, for that it will start the services, and it will create one network as well for it. There are multiple network types available, that is the host network, bridge network, whatever. It will create the bridge network for us for the different services that we have, and it will give the name as well. So all those services will be there within the same network. So whenever we want to refer to any of the services, we can refer using the service name itself. So this gives us the extra functionality as well when we are working with the Docker Compose. Okay, so now what I want is, I want to add the depends on functionality, like this service registry should start first, and then once that is done, I need to start my config server. So that means my config server will be dependent on my service registry. So whenever the container will start for the service registry, then the container for the config server will be started. And my cloud gateway is dependent on the config server. So whenever the container for the config server is getting started, after that my cloud gateway should get started. Okay, so let's add that as well. So we'll just add depends on, and here we can pass the list. So we can pass the multiple list. So here for service registry we don't need, so let me just remove from here, and I want to add here. Okay, so this is dependent on service registry. So I'll just mention this is dependent on service registry. Now I will copy this as well, and I will mention here your indentation should be correct in the YAML. Okay, so make sure you add the correctly. Now my cloud gateway should be configured, or should be dependent on my config server. Okay, now one more thing we had done, like whenever we were working with the command, right, we used to pass the environment variable as well, like which environment variables are there. So those environment variables also we can define here. Cool, right? So let's define those environment variable as well. So here within the service registry there was no environment variable, right? Because this doesn't need any environment variable. Config server needs the environment variable, that is the service registry server URL, right? So let's give those information here. So I can define those using the environment attribute, environment. Okay, and this is also going to be the list, so I can add multiple. So what I wanted was, if I go here, if I go to the config server application.yaml, this is the one, right? So I'll just copy this equals to, I'll copy this, right, equals to this. So I am giving the URL address for the Eureka server, but we saw that we were giving the host.docker.internal, right? So this way we can give here. One more thing I mentioned, that everything will be created within the same network, right, when we are working with the Docker Compose. And if everything is there within the same network, I can access this information, I can access the network, or I can access the other services based on the name itself. So if I don't pass host.docker.internal, I can still access using the service registry name. So if I pass service registry instead of host.docker.internal, this will also work. Okay, so let's pass this, and it's more readable as well, right? So we'll pass this. The same information I can pass for my cloud gateway as well, right? So let's do that. Now cloud gateway will need one more environment variable, right? So let's define that environment variable as well. So that environment variable was, if I go to the cloud gateway and if I go to the application YAML of cloud gateway, you can see that one was config server URL. Okay, so let's add that as well. So config server URL equals to config server itself. So here you can see that you have defined your entire Docker Compose. Now let's see how we can run this. So let's go to the terminal, okay? And here we have this Docker Compose YAML file, okay? And currently if we see with Docker PS -a, there is no services available. Cool, right? Let me clear that as well. So now to run this Docker Compose file, what simply we have to do is we have to use Docker Compose command. And if you want to see the help, you can go ahead and see the help information. You will get everything, okay? Docker Compose, and you can see that you need to give the file information -f with the file, okay? And if you want, you can give the project information, and there are the different commands available. All these commands are there. So let me just clear this, and we will just do Docker Compose, and then with -f we will give the file information that this is the file that I want to use, that is Docker Compose -f Docker Compose YAML. And what I want to do is I want to up all the services, so I'll just define up up, okay? And I can pass -d to run everything in the dash mode. I'm not passing it everything, so I want to show you the logs as well, because everything will start together and all the different logs also will be mentioned. So let's start all the services all together. And if we just hit enter, you can see that first it is trying to create a network, okay? After that you can see that all the containers are there, and you can see that different colors are mentioned for the different logs, so you will be easily able to identify different things. So you can see that everything is running here, right? And if we go back here and if we go to the Eureka, you can see that your Eureka server is running, your config server is running, but I'm not able to see my cloud gateway. Okay, so let's see what happened. So if we go back to our terminal and if we go to the cloud gateway here, right, this is the cloud gateway logs, and you can see that it's showing it exited with code 1. So what is the error? The error I can see here, let's scroll up, right, we will see what is the error. And I can see the error that it could not locate the property source of the resource is not optional. That means whatever the config server that we have defined, right, it was not able to get those information, but we have the config server running, right? We have the config server running, but we need to understand this, like whenever we add the depends on, right, if you go here, whenever we add the depends on, what it will do is it will only wait until that container is started. It doesn't mean that your application inside that container is started. Okay, so the moment the container of the config server is started, your cloud gateway will get started as well. It will not wait until your config server is started and config server is started giving you the configuration. So to prove this, what I will do is, let me just open this, and if I do Docker PS, so you can see that 2 services are running. Okay, but if I do Docker PS -a, this is my 3rd service which is not running, that is exited 2 minutes ago. Now if I start this again, it should get the config server, because now config server is already running, right? So if I start this Docker start command, and I'll just give the container here, and you can see that the container is started, right? And here you can see that I am getting the cloud gateway logs now. Okay, and you can see that your cloud gateway is started, and now it should be able to connect to my service registry as well, because so now my cloud gateway will get the configuration from the config server and it should be able to connect to my service registry. So if I go back, if I refresh, you can see that my API gateway is now also available. So that means that depends on doesn't wait until your application is started. So we need to make sure that we implement this functionality, right? That until and unless my config server is started, my API gateway should not started, then only it should get started. So it will work fine. So what I will do is, let's do that configuration and let's clear it out everything whatever we have created. So what I will do, I will just do Control-C here. So you can see that once we do Control-C, everything will be stopped now. Okay, everything is killing. So let's do Docker PS again. Okay, everything is stopped now. I will remove all this container. So Docker PS, sorry, Docker RM. Okay, everything is clear. If I do Docker PS -a, I should not get any services. Okay, so now let's implement the health checks. So if I go to my YAML file, what I want to do is I want to start my cloud gateway after my config server is healthy. Okay, that's the one thing that I want to do. How I will get to know that when my config server is healthy? So whenever I'm able to hit my config server itself, right? Whenever I'm able to hit my health endpoints of my config server, and if that shows that this is healthy, after that I want to start my cloud gateway. That's a simple thing I want to do. So for to implement this, depends on attribute is not enough. We need to add the health endpoints as well, health checks as well. So let's implement the health checks that will allow us to start my cloud gateway once my config server is healthy. So I will not encounter with the failures that I got. Okay. So let's implement this. So here within the config server, I will implement the health checks. Now let's go here and implement the health checks. I will add the attribute health check here, and within the health check I need to add the test command. What I want to test, I can do the curl command for the health endpoint that I have. Okay, in our config server we have added the config server dependency, so health endpoint will automatically come with that, which will allow us to hit that endpoint. And if that endpoint is available, if I'm getting the success result with that, I can say that my health checkpoint is working fine. Okay, my application is healthy. So let's see that. We will add the commands here. We will do the cmd command. Cmd command is used to do the any commands on the Docker containers. Okay, so we'll do curl command with -f, and then we will add the URL. So we will just define http config server, because we can access using the service name itself, 9296/actuator/health. This is the default health check endpoint. Okay, whenever you add the actuator, this is the health point you will be using, and you can define on what interval this health point should work. So I can define interval should be maybe 10 seconds, and I can define timeout as well for 5 seconds, and I can define how many retries I want to do. So I've defined the health check over here for my config server. So now Docker will know that when this particular service is healthy. Okay, not the container is up. It will know that whenever this is healthy. So whenever this test is successful, Docker will mark this config server as healthy. Now what I want is, from my cloud gateway, I need to make sure that whenever the config server is healthy, then only start this cloud gateway. Simple, right? And not just depend on config server. Depends on config server with the condition. Okay, and in the condition I'll mention service as healthy. So there are a couple of options available in the conditions, which condition you can pass. In this we are passing the service is healthy. So whenever this config server will be marked as healthy, then only my cloud gateway will start, because in the depends on we have mentioned that this config server's condition should be healthy, then start this. Now let's start this again. So let's go to the terminal, and I will use docker compose command, docker compose -f, docker compose YAML up with a detached mode. Okay, now you can see that this is in the detached mode. So it will create the, so you can see that first service registry was started, then config server started, and your cloud gateway is just created. It will wait until this is healthy, and then you can see that it got started. Now you can see that this is also started. Now if I see with docker ps, okay, you can see that everything is started, and you can see there is a mark as well that your config server is healthy. So once this was healthy, then only it got started. Okay, you can see the gap as well when there is a difference in the timing. So now if I go back and if I refresh, you can see that everything is connected, everything is working completely fine. Cool, right? So this way you can use the docker compose command to mention each and everything, like what images and what services you need, which is dependent on what and everything, and it will just start everything for you using one command. Now how about deleting everything? So the command to delete each and everything would be just docker compose -f docker compose YAML with the same YAML configuration. If you just do down command, it will bring down each and everything, and it will delete the containers as well for me. So you can see that container was stopped and then removed also. And you can see that it will do in the reverse order because we have added the dependencies accordingly. So you can see that everything is removed now. If I clear this and if I see docker ps command, you can see that there is no containers available. If I see with docker ps -a as well, there is nothing available. Only I'll be having the images. So you can see that how easy it is to work with the docker compose. So this was all about the Docker Compose and how you can create the Docker Compose files and how you can start the Docker Compose services and bring down all the services. Now in the next video, we will see how to automate the project building, image creation and pushing those images to the registry in a simpler way, in the simple steps. Because if you remember, we did a lot of things. We were doing the mv clean install to create the images or to create our jar files. Then we need to have the Docker files. We need to create the Docker files, and after that Docker files, we were creating the images out of it, and then we were pushing those images to the Docker repository. So we will simplify all those steps in the next video. Now let's talk about Maven zip plugin, which will allow us to package our applications into our Docker images very easily. So let's go ahead and see this in action. So let me just go to the browser and let me search for the Maven zip plugin GitHub. So this is the zip Maven plugin GitHub page over here, and from here you will get all the information about how to use zip plugin in your Spring Boot projects. So you can see you will get all the information like zip is a Maven plugin for building Docker and OCI images for your Java application. So it's an open source plugin by Google which will allow us to package our applications into Docker images. The main thing about this is it will allow us to create the Docker images without the use of the Docker file, plus without the use of the Docker install as well. For of course, if we want to run our Docker images, we need to have the Docker, but to package this using the zip in the Docker images, we do not need the Docker as well install. Zip will do all the steps. If it will package our application and it will push our Docker images to the repository altogether. Okay, so we are going to use this plugin in our applications. So if you scroll here, you will get all the information and you will get the plugin information as well, like how we can use this particular plugin. So what we will do is we will use this and we will add in our IntelliJ IDEA in our pom.xml file. So what I will do is I will be copying this plugin section, and this plugin we will be adding in our pom.xml file. So let me go to the IntelliJ IDEA and let's start with the service registry first. Okay, so what I will do, I will go to the service registry. Let me close all this file here first. Okay, I'll go to the service registry, go to the pom.xml file, and here what I will do is I will go to the plugin section and I will add the plugin. So you can see that I just added the plugin, that is com.google.cloud.tools as a group ID and zip Maven plugin as the artifact. Just add this information and the version information. Let me just remove the version as well, because with the Spring parent it will take the latest version available. And now here in the configuration we need to add all the information. If you see the Docker file, whatever we have added, right, like from which particular base image we are building our Docker images, that we need to add, and all the other information. The similar thing, we will add those configuration directly in our pom.xml file. So here in the configuration we will add the fields. So here in the configuration we will add from which particular image we want to use. So I will just define from image here, and we will define that we want to use OpenJDK 11 version. Okay, this is what we have defined. Now from this image, what we are creating, two image. So here we will need to define our image name. So here we need to define our entire repository, full repository name and the image name. So our repository is where the Docker IO, right? That is the registry.hub.docker.com. So we will define that as well, registry.hub.docker.com. Within this, my repo is daily code buffer. Let me just spell it out correctly, daily code buffer, and slash what would be the name of my image. So what I will do is I will use the same name as the group name here. Okay, so this is the artifact ID, right? So this is something that I will use. So you can define this as well, that this is the artifact that I want to use, or you can give any other name as well. So let me just define service registry here, and if you want, you can define $artifact ID as well. Okay, this way. So here I will define service registry, and within the tags information we can define the tags. Here I will define $project.version. Okay, so let me just define this way, that I'm defining project.version, whatever the version would be. Currently you can see that the version is 0.0.1 snapshot. I can change to 0.0.1 as well, and here you can see that I have just modified my POM configuration which will be using my plugin, that is the Jib Maven plugin, where I have defined the configuration, like which is the base image I want to use and what image I want to create out of it, and what would be my image name, and what would be the version information. Simple. Okay, so this is the only thing that we have to define. Now other than that, what we have to do is we have to do the Maven configuration as well in the settings.xml file. If you are not aware, Maven uses the settings.xml file. If you go over here in the Maven, if you go to the configuration and Maven settings, you will see that there is a user settings file within this particular folder. Okay, so if I go here in my M2 folder which was mentioned, this is the settings.xml file. If you do not have the settings.xml file, you can create one, and in this settings.xml file we will define the configuration for our Docker repository. Okay, which means we will define our credentials, because this particular configuration, it will try to create the image and it will try to publish to my Docker hub, to my registry. But for that we need to authenticate as well, right? We need to give the authentication detail as well. So rather not giving the authentication details here, we will give the authentication details in our settings.xml file, which we are not going to commit, which will be in my local always. So if you say this is going to be your configuration file. So I'll be providing this settings.xml file. You can save this as a settings.xml file in your .m2 folder, wherever your Maven is pointing to. Okay, where we have defined the server information. Within this server we have defined that we are going to connect to registry.hub.docker.com. This is our Docker registry, and within that we have defined our username and password. You have to give your username and your password. Just add this information and rebuild your projects. Once you have defined the settings.xml file and you have defined this configuration, we can build our project. So what it will do, it will create the project. That means it will create our jar file, and with that jar file it will try to build the Docker image, and that Docker image will be published, it will be pushed to our registry. Everything it will do automatically. We do not have to do anything manually. Okay, so if you go to browser and if you go to Docker Hub, currently you can see that there is a service registry available, but this is with a dash and this is 1 year old. Okay, now we will go back and we will go to service registry. We will open the terminal here. Okay, and here we will do mvn clean install jib :build. This is the Maven command which will clean the project, install, it will create the package for us. Okay, and then it will use the jib: build plugin to build our Docker image, and it will publish it. Okay, everything it will do here. So let's run this. So you can see that it is running, and you can see that build happen, and it is trying to push here as well. So you can see that pushing blobs. So we will wait for it to complete. So you can see that it is publishing to our repository. Cool, right? You can see that build is successful, which means my build and pushed image also completed. Okay, here you can see that registry, Docker Hub, daily code buffer, service registry, and the version is this. Okay, now if I go here, you can see that there is two available. Okay, one is service registry and one is service registry 0.0.1. So by default it will also create one tag for the latest tag. One will be latest and one will be 0.0.1. So if we go to the browser again and if we refresh our page, that is our Docker Hub, you can see that daily code buffer / service registry pushed a few seconds ago. Okay, and if we go inside that, you can see that we have two tags available, that is 0.0.1, which was the tag that we mentioned, and one was the latest. So you can see that it will create the two tags. So whenever we will do publish, the whatever the latest version would be, for that latest version the latest tag would be created for us. So always we will be creating this way two tags, and you can see that with just one command we were able to push everything. Right, now one more thing, this service registry will not be available within your local environment currently, because it will not use Docker. It will directly package everything and it will push the registry. Now if you want to use this image, you can take this image and you can pull this image into your Docker environment and you can run this. Similar way how we run when we created the image using the Docker file, you can also use this with your Docker Compose as well. So this is, and if you go to the public view, you will get all the information as well here, that these are the tags information. Okay, you can see these are the tags, these are the digest and version information, and everything you will be able to see here. Okay, similar thing, you have to copy this plugin and you have to add in all your projects. That's it. What you have to change, you just need to change the name of your image. Okay, that's it. If you do this and if you run this command, you will be able to create the images for each and everything. One more thing you can do is you can add this particular steps, right, this particular plugin into your Maven phases as well. So whenever you will do mvn clean install, if you want at that time only you want that everything should be created, that also you can do. That configuration is also available when you go here. So if you go here, okay, if you scroll down, you will get all the configuration. You will be able to see each and everything. So you can see the command is available and everything is there. Okay, and you can see this step, build bind into lifecycle. So if you define this execution phases, so at the time of build and packages, if you want to create your Docker images, that also you can do. You don't have to mention zip build. By just mentioning the mvn clean package, you will be able to create your jar file, create your Docker image file and publish that image file to your repository. Everything you can do within the lifecycle itself. So you can see that how easy it is to create our Docker images using the zip Maven plugin. So the homework for you would be to implement the same thing in the other repositories as well, and make sure that all those repositories have this plugin and you are able to publish all those repositories, all those image files to your registry. So that's all with the implementation of the zip plugin, and that's how easily we were able to add the zip plugin. So that's been it in the Docker course. If you want to learn more about the Docker, then all the useful links are available in the description below, with the Git links as well, whichever the project that we have covered. So you can check out those projects and you can learn more as well. If you have any doubts regarding any of the things that we have covered, then do let me know in the comment section below. Also, subscribe to my channel for the upcoming videos, and also hit a thumbs up on this video so more and more people can view this course. So that's been it. I will see you in the next video. Till then, happy coding. Bye bye.